Okay, so the first thing that I want to do is I want to talk about what perpendicular and parallel mean today. Okay, so we've already learned about parallel. Do y'all remember what the symbol for parallel is?
Double L.
Okay, it looks like double L's. Yes, I just told you. All right, so this means parallel. Now the definition of parallel lines, what does that mean?
The same slope.
Okay, two lines that never intersect. Okay, and they do have the same slope. Okay, now it's been a while since we marked parallel lines. Do you remember how we mark that two lines are parallel? Okay, it's like an arrow type thing. So here, if AB is parallel to CD, you can either write it like this arrow, or you could write it as this arrow. So either one of them is fine. That's how you show that they're parallel. Now, just because they're parallel, does that mean they're congruent? No. So don't get confused when we start writing proofs and think that they're congruent. Okay? Now, for proofs, anytime you have parallel, we're going to be looking for alternate interior angles. Okay? So every single time we do a proof, we're looking for alternate interior. So if I was looking for alternate interior angles in this figure, where would be my transversal here? CB would be my transversal. And so my alternate interior angles would be either this one and this one. Those are alternate interior to each other. Or this angle and this angle. Okay. Now in this other figure, which one would be my transversal? CB. Or you could do AD. We'll do CB first. So if we do CB, my alternate interior angles would be angle B and angle C. Now, we could also treat the other one as a transversal. And what would my alternate interior angles be? Angle A and angle D. Very good. Okay, now let's talk about perpendicular. So what does the sign for perpendicular look like? Upside down T. Okay, and what does the upside down T mean? 90 degrees, or you can say right angle. Okay, so here it says NO is perpendicular to ME. So NO is here. ME is this bottom piece. Where they intersect is where the 90 degree is made. So it's made right here where they intersect. Now, the way this is going to be useful in a proof is if angle MON and angle EON are both 90, doesn't that mean that they're congruent? Okay, so since they're both 90, if we were writing a proof, we'd put angle MON is congruent to angle EON. Okay? So if they're the same angle measure, they're congruent. Is that pretty simple? No, the sides are not, just the angles. Okay, so let's try a proof. So let's look at number 1. So in number 1 it says A is parallel to C. So how do I label that those are parallel again? Okay, so AB is parallel to CD. So I'm going to put the arrows. Now remember, that does not mean that they're congruent. Okay, just swap B and D for me on your paper. I'm sorry, it's backwards. So swap your B and D and then draw your chart, because we don't have the charts drawn today for us like we did yesterday. So remember, it is labeled statement and reason. Okay, so what's the very first thing that I write? My given. So my given is AB is parallel to CD, and angle A is congruent to angle C. And we know that because it's given. Okay? So we labeled that these were parallel. Next we want to label angle A is congruent to angle C. So A is here. C is here. Those are congruent. Now, we don't have any other steps yet. So yesterday, our proofs told us something where we wrote down steps, right? Today, the proof is not telling us anything that writes down steps. So now we're going to have to look at the picture and look at what's implied. So when I was talking about parallel lines earlier, what did I say we always want to look for with parallel lines? Alternate interior angles. So let me go ahead and circle my transversal. So my transversal would be DB. So there are actually two sets of alternate interior angles. It does not matter which ones we use. I'm going to use this angle right here, which is ABD, and this angle right here, which is CBD. So I'm going to write down that those are congruent. So I'm going to put angle ABD is congruent to angle CDV. And what's the reasoning behind that? Anybody know? It would be alternate interior angles theorem. Okay, now I have an angle and an angle, an angle and an angle. Is it going to help me to prove that these are alternate interior and have three angles? No, because does angle, angle, angle work? No. So now I need to find a side. So does anybody see a side in this picture that is the same? Okay, it is, Amy said, DB and BD. Do you see how it's part of both triangles? They share it, so it is reflexive or congruent to itself. So number 3 would be that DB is congruent to BD, and that is the reflexive property. Okay, and so our fourth step, now that we have an angle, and a side, is to prove how these are congruent. So I'm going to go ahead and write my proof. Remember, write it just like this. So triangle ABD is congruent to triangle CDB. Okay, and what is the theorem? If we have two angles and a side. Angle, angle, side. Very good. Okay, so we are going to look at another one like that just to make sure we got that. So let's look at number 2. Okay, let me see if I have that one. No. Okay. 5 is the same, right? Okay. Well, then I will draw the one that you have. So y'all's looks like that. And we have P, A, S, K, and R. Okay, and so our given says that PA is parallel to KR and PA is congruent to KR. And we want to prove that triangle PAS is congruent to triangle RKS. Okay, so first thing I want to do is draw my two-column chart. I'm going to label it statement, and reason. Okay, so my first thing that I write is my given. So PA is parallel to KR, and PA is perpendicular to KR. And that is because it's given. Okay, so let's label that. PA is parallel to KR means that I'm going to put these arrows on it. But then it also tells me that PA is congruent to KR. So I need to put a tick mark letting me know that they're congruent. Okay, so on both of those, do we need to write down anything for this? Yes or no? Nope. So now we're looking at everything that is implied by the picture. So anytime we have parallel lines, we want to look for what? Alternate interior angles. So which one of those do you want to be our transversal? KA. So we're going to use this as our transversal. So that means K and A will be our alternate interior angles. So I need to write, if they're alternate interior, they're also what? Congruent. So put angle K is congruent to angle A, and that is alternate interior angle theorem. Good. Now, do you want to do the other set of alternate interior? You'd rather do vertical? Okay. You can do the other set of alternate interior, or you can do vertical. Either way would work. No, it wouldn't add another thing. Okay? So y'all said you'd rather do vertical. So we're going to do vertical angles. So that means that angle, and we can't just label this S because it shares both. So one of them would be PSA. Angle PSA is congruent to angle RSK. And that is by vertical angle theorem. Okay, so looking at this triangle, would this be what would this be proved by? What theorem? Does anybody agree with him? Okay, so we can either say side, angle, angle, or we can say angle, angle, side. Either way, that works, but we cannot go angle, skip a whole side, and an angle to the side to the angle. Does that make sense? So most direct path, angle, angle, side, or side, angle, angle. The other proof, yes. Had you used the alternate interior, it would be angle, side, angle. So there's two ways to do that proof. Okay, how are we feeling about parallel proofs? Okay. Let's try a perpendicular next. So number 5 on the back is what we're going to look at next. So go ahead and draw your T-chart. Write statement and reason. In the first step, we're going to write our given. So OK is perpendicular to DR, and DK is congruent to KR. And the reason for that is because it's given. Now we're going to label that. So if OK is perpendicular to DR, so where OK hits DR, right here is perpendicular. So what should I draw right there? 90-degree angles. Okay? And so what did I say it meant if both of them are 90? What do we know about those angles? They're congruent. So I need to write that those angles are congruent because it doesn't say it up there. So we would write angle DKO is congruent to angle RKO. And so do we know why that would be true? What does it tell me up here, right here? So it would be definition of perpendicular. Okay, the next thing that I want to label is DK is congruent to KR. So DK is this piece right here, is congruent to KR. Now, do I need to write that in my proof? No, because it's just given to me. Okay? So now we've done everything in our given, so we have to look at what's implied by the picture. So, does anybody have an idea of what may be applied? Yes? Very good. OK is shared in both triangles, which means it's congruent to itself. So OK would be congruent to KO by the reflexive property. Okay, and then the last thing is to prove. So I'm going to write triangle DOK is congruent to triangle ROK. And looking at this first triangle right here, it's side, angle, side. Does this one match? Side, angle, side? So it would be side, angle, side. Okay. Let's do one more perpendicular to make sure you have that. So do y'all have that one? Okay, so for this one, the first thing I want to do is draw my T-chart. We're going to have statement and reason. So the first one is going to be my given. RJ is perpendicular to GE, and angle 1 is congruent to angle 2. And we know that because it's given. Now let's label. So if RJ is perpendicular to GE, where RJ and GE hit, I'm going to draw 90-degree angles. So what does that mean about those two angles if they're both 90? They're congruent. So I need to write down that they're congruent because up here it doesn't tell me the angles are congruent. So what would this angle right here be? You can say RJG or GJR. Either one is fine. I'm going to do GJR is congruent to EJR. And that is because the definition of perpendicular, it tells you right here. The second thing I want to label is that angle 1 is congruent to angle 2. So angle 1 is here. Angle 2 is here. Do I need to write that down? No, because it's just given. Okay. Now, we've done everything in the given, so we're looking for something that's implied by the picture. So, yes, we have two triangles right here. They both share side JR. So that means it is congruent to itself. So I'm going to write that JR is congruent to RJ by the reflexive property and so all that's left, because we have angle and a side and an angle, and that same angle side angle, is to prove that they're congruent. So I'd write triangle GRJ is congruent to triangle ERJ. And what's the theorem? Angle, side, angle. Perfect.